Hi, everyone, and thank you for joining us. We appreciate that you're spending some time with us. We know you have a lot of other good things to do. Maybe you came in just so you could have a nice bite to eat in solitude. I don't know, but we are thankful any way you look at it. One thing I would like to ask is to help us get to know you a little bit. So how many of us here are primarily administrative in the work we do? Nobody? Okay. Devs? Okay, 3. How many of us are generalists? Anything like that? Okay. What else is there? Anyone here a manager, maybe? Or you don't do anything? Okay, good.
SREs.
Yeah. SREs, yeah. Any of those kind of roles? No?
All right.
Okay. So what we're going to talk about today, we have kind of 3 segments. The first is SolarWinds and what we do in the open source community. And also the projects that we contribute on. And then finally, we're going to talk about the way we support open source and different platforms and so forth. So SolarWinds is primarily about observability and monitoring. So we'll show you how we actually take all the work that we do in open source and the different builds that are out there, and how do we put that into use in our system. Now, also, as we go along, feel free, if you have a question, you want us to stop and explain something. Just to take a quick moment to introduce ourselves, you've got a mic over there. My name's Kevin Kline. I'm a technical evangelist, particularly for the database side of our business. I've been in databases since 1986, when I started working for NASA, building the water recycling system in the space station. And back then, on Oracle 5, we thought our 128 megabyte database was practically infinite in its use. I mean, just huge, right? So guys, why don't you take a moment and introduce yourself?
Hey everybody, my name's RJ Gazarek. I'm a Director of Product Marketing for SolarWinds, focused on our growth products, so I do database and service management.
Hi everybody, my name is Bradley Sisson. I'm a Senior Solutions Engineer. I focus primarily on our SaaS offerings, and I've been with SolarWinds for 7 years.
Nice.
Hey guys, Ted Lasso. I coach a small football club no, I'm just kidding. Rob Mandeville, I'm also on the product side.
Excellent. Yeah, so anything related to APM, Application Performance Monitoring? Bradley's our guy. Anything about the database products that we have? And we have several. Rob is our person, or I can also answer those database questions. So let's dive in. All right, so we do engage in quite a few different open source projects. However, our biggest contribution as a monitoring and observability organization is to the Open Telemetry project. Is anyone here a contributor to an open source project? Either using forks or maybe you even do upstream work? No? Okay. So we do a lot of work in the Open Telemetry project, as I mentioned. And that is, there are many different foundations, and we see some with booths here even. So you're probably familiar with the Apache Foundation. This is under the Cloud Native Computing Foundation. And if you've never heard of OTel, Open Telemetry, it's a framework that we use to kind of standardize all of the collection, the generation of telemetry, transmitting that, and we use all of that telemetry in that standardized fashion so that we can accelerate the way in which we can bring in new platforms. So the collection of logs, the collection of metrics and traces and so forth is all standardized, and it makes it much easier to support. We also, as you'll see in a moment, we do that in reverse, because each of the different main languages supported by OTel, for example, Java and so forth, Python, they also need their own customizations for them to work. As I mentioned, it's vendor neutral, it's API driven, there's SDKs, there's tooling for it, and it enables you to integrate with all these different libraries and different frameworks. So it's very versatile. It's a very easy way to get going with telemetry. So rather than like with a Windows-based set of infrastructure, you would be looking at perfmon counters and the event viewer. And then on Linux, you would be looking at different things. And with, say, a different database, you might be looking at different counters and logs traces. This is all standardized for you, so it makes a very easy process, okay? Now, of the companies and communities and individuals that are contributing to OTEL, we're in the top 25. And our observability APM instrumentation team adds back, right? So we give a lot back to this project. And a couple of our engineers are quite well known. They are approvers of changes. So Tammy Bayless and Zhao Cao work on the different language implementations. So Python and Ruby. In fact, let me flip over and show you, just in case you didn't know these things existed. It's kind of neat to see. So they have some really nice Grafana-style dashboards that tell you what contributions are like and who is making the biggest contributions at any given time. There is also, let me make that a little bit smaller so we can see it easier because it's cut off at the top. Come on, there we go. So there's a lot of community resources in case you ever want to grab any of that. Guidelines, and one thing I will also say is that you don't have to be only a developer. There's a lot of need for people to write docs. There's a lot of need for people who speak multiple languages for translation and so forth. So it's a community, and you can get involved, and you can contribute back to the OpenTelemetry community. If you don't want to, and you just want to take advantage of what it offers you, then you can just go straight to GitHub, fork that code base, and start to use it yourself, okay? So let's move on a little bit more. So as I mentioned, we're big on the contribution to OpenTelemetry. We use it corporately, I guess you should say. We do OpenTelemetry collector for the host monitoring of maybe the host that has multiple guest VMs underneath. Network collector for Kubernetes. Anyone use Kubernetes here? Oh, right on. Okay. Is Docker dead? It should be. Okay, all right, thank you. OpenTelemetry for APM, so application performance monitoring, which we're going to show you a demo of that in just a minute. And then APM libraries. So a lot of good work that we take advantage of and you can take advantage of too. So I'm going to hand it over now to Bradley, and Brad's going to show us a little bit about the way that the SolarWinds observability works and keeps an eye on both your applications and their interactions with the back end.
Hey, good afternoon, everybody. As Kevin mentioned, this is the SolarWinds observability platform. It is a SaaS-based offering from SolarWinds that has a lot of built-in capabilities, and specifically those that we're going to talk about today are more around the APM functionality, but it does have a variety of other infrastructure, network, and synthetic-based monitoring that can be leveraged here. So in this particular example, all right, sorry. We're going to look at a service that's part of our Swapper application. This is just a little demo application. It's basically a little web store that people can buy things on. So what we're going to start with is the front end service in just a moment. My goodness, okay. Apologies here, a little small, but when the instrumentation gets added to the application, we're going to be able to pull out a variety of metrics, primarily focused on things like request volumes, response times, and error rates. We will automatically split a given application or service into transactions, as well as be able to provide some high-level insights associated with things like the types of remote calls that are being made over a particular time frame. So we can see when those calls are being made to another instrumented peer service or a downstream service, as well as calls to like a generic third-party API or some other web endpoint that's not been instrumented by the application. Ultimately, the type of information we can gather here, how is this request being made? Is it a GET? Is it a POST? Is it a PUT? Whatever the case may be. Is it HTTP or HTTPS? And then what is the average and total durations that we've seen the application spend on making such requests over the time frame that we're looking at? The ultimate goal here is to eventually get to the trace level of visibility. What this is going to provide is an extremely granular, detailed view of the calls that are made by the application, as well as be able to get down into some code level analytics. So bear with me for just one moment. We'll just pick one of these traces in particular. And what we see here is a typical kind of transaction for someone trying to purchase something on the web store. So we can see that the initial span layer here, the entry point is the submit order transaction. We're doing a post. Essentially what it's going to do is kind of percolate through some of these other services. You'll see like this ASP.NET Core span layer is associated with the cart service. Again, as we continue on a little bit further, you can see things like the inventory service and the order service. Again, this is ultimately just giving us a complete picture of what's happening behind the scenes when someone's trying to buy something on our web store. Now, each of these spans from up above are going to be represented in this table down below, so you can see the relative start time, the percent of the total trace duration that this represents, as well as the full duration of that individual span. We can also drill into those spans and get a deeper picture of how this request is being made, how it's being handled, things of that nature. We can see like the URL path. We can see the user agent that's being used to make this request, and so on. This is also where we access the code profile. And again, what this is going to give us is a line of code level visibility. It's going to be a percentage of time breakdown that we detected individual methods running throughout the course of this request. So you can use this to help identify bottlenecks. If there's a particularly long-running method that needs to be addressed, you have the ability to identify what that might be. Take this, and if you're a developer yourself, use it or pass it off to the appropriate individuals. So similarly to capturing typical kind of like web calls, we're going to separately categorize the queries that get run as a result of this. So you can see those queries have been normalized here. You'll see the count of executions, the average, and the total duration. Because they've all only been executed once, obviously those are going to be the same, but ultimately, again, just trying to provide you as much detail as we're able to in this kind of single view with this extremely focused visibility into this particular request. Another capability of the platform is to ingest log data, and we're actually able to correlate the log data with a specific request. In this case, we're using the trace ID. This is a unique value that the APM instrumentation will add to basically the request headers that are being made by the application. And then we'll be able to print those into the logs, use that as the anchor point to show the specific logs associated with this request individually as opposed to more broadly just from a specific time frame or something like that. So excellent. Are we doing questions? Any questions? Yeah. Good choice. Okay, cool. So to take this a step deeper, we're looking at this from the application perspective, but we do also have a lot of capabilities around the database monitoring space here. So looking at this top level, we see high-level quality of service metrics, things like average response time, throughput, error rate, and so on. What I really want to get down to, though, is the samples that we take. So these are actual occurrences of a query being executed against the database here. And if we scroll down a bit, it doesn't look like I see any recently. We do have the ability to associate that with a particular trace. So where possible, you could actually connect the APM data to a specific sample that was taken by the database itself. In lieu of that, I'll just kind of show some other kind of query that maybe has some additional detail here. If you give me just 1 second, this will be a good one. So this is a Postgres database. You can see our select statement. It's going to go through and do some joins and some other various things with this query. But we're actually seeing this as a real-world example, right? So where was this request made? What is the actual database name being accessed? What's the user making the request? And so on. We also can generate this explain plan in JSON format, as well as the visual explain plan, which really helps kind of show where time is being spent, where resources are being spent throughout the course of this query being executed. Again, as I mentioned, the platform has a ton of other functionality baked in. We're trying to kind of keep it short and sweet, focused on the APM-centric data here, but we do also have kind of the more infrastructure side, which would allow us to monitor something like our Kubernetes clusters. This will give us insight into kind of the inner workings of the cluster as a whole. So we'll see things like the nodes on that cluster, the pods on the nodes, workloads that are distributed throughout. This also gives us good visibility into the network traffic that's going on within the cluster. So we're actually able to show bandwidth utilization, errors, numbers of requests, and things of that nature within a given cluster in like a visually kind of applicable way. So you can kind of see as we have some of these different services. Again, this is the cluster that Swapper is running on, so you can see as the front-end service is calling the inventory service, and the inventory service ultimately goes back to the MySQL database. You can see we've got like Kafka in there, we've got Nginx in there. Again, ultimately, this is more gathered from the Kubernetes perspective, but it does give us some really great insight that we can use to correlate with like the APM services that run on this cluster, right? So if we tab over here, we can see our front-end service and our cart service, and so on and so forth. With the Kubernetes monitoring as well, we do pick up events from the cluster, so we'd be able to see as it's going through various kind of checks and containers are being recycled. And this is, of course, in addition to whatever other APM database log and infrastructure data we can collect. Fantastic. I think I might hand it back off unless there's any questions that I could try and help answer from the audience.
Yeah.
Oh,
Sorry, go ahead. I'm sorry.
no, that's okay.
And I came in late, so you might have already covered. So how is the system secure and backed up? Just curious. I saw the graphic, I didn't see it.
Sure. Yeah.
And could you repeat the question?
Yeah. The question is basically how is the system secured and backed up? This is a SaaS offering from SolarWinds, so we host it on AWS. Obviously, you know, traditional kind of security things. We're SOC 2 compliant. We do have the, you know, availability zones running for backup and redundancy and things like that.
You said this is SaaS. Is this available for on-prem?
SolarWinds, as an organization, we have an on-prem or self-hosted option, but it's not an exact one-to-one with what you see here.
Like case inspection of APM monitoring?
Those are pretty much the SaaS, basically the most prevalent SaaS features. Yep.
Can it only run Kubernetes components on the on-premise? Like we have clusters on data center. We only want to monitor and look at the logs on Kubernetes clusters only. Can we do that? We don't want other things.
Yep, it's totally a la carte. You can pick and choose whichever modules you'd be interested in. It's also worth noting that if you're utilizing the Kubernetes functionality, it does not have to be a self-hosted Kubernetes cluster. It can be like an AKS or an EKS cluster, so you can still add the instrumentation even if you don't own the underlying infrastructure.
And how does it read like all the metrics like inside the cluster? It runs the daemon set.
Yeah, it's a Helm chart deployment that you would do.
And for the network observability of Kubernetes clusters only, like is it something? What is behind that? Is Jaeger network observability? What is it?
That's getting a little bit out of my personal realm of expertise, but I could meet up with me after and we'll figure it out.
Yeah, stop by the booth and we can dig in a little bit more. Can you guys, does this work?
I think it's off.
Any other questions?
Thanks, team.
All right, thank
Yeah, one of the cool things about this is that I'm kind of used to seeing metrics and from different parts of the IT stack, or maybe from just within the containers, or maybe from the network side or infrastructure. Really, it comes across as disjointed, though, right? In the traditional kind of system, it's like everything does its part, but then now it's up to me to have to stitch it all together in my mind, right? Because we have all these dependencies. One of the really cool things about this is that we link all those together. And one of the key things is linking from the APM tier to the database tier by that trace ID that Bradley was mentioning. So,
And we'll dive in a little bit deeper on that in just a moment. Some of the things we didn't have time for were to talk about, like the APM monitoring specifically by languages like Java and PHP, those kinds of things, Node.js, Python. We also have specific log monitoring products, as well as real-time application monitoring and application crash monitoring. So if you only wanted to know if the app was up or down, like you were saying, I only want Kubernetes. Well, if you only want to know app is up or down, we have other tools for that. So that would positively impact the total licensing fee if you went for something small as opposed to everything that can be monitored. In just a moment, Rob's going to dive in and show us more about the database monitoring. These are standalone tools, so they don't have to be part of that big, the big SolarWinds observability platform in the sky. You can buy database performance analysis by itself. It supports way more than a dozen database platforms. So all of the commercial platforms like Oracle, Microsoft SQL Server, also supports all of the commercial platforms of the open source databases, so like Percona PostgreSQL, and Enterprise DB, another commercial version.
MariaDB stuff.
MariaDB and all that. In case you didn't know, Progress Software's here, and they recently purchased MariaDB, so they are now the owners of that. So, as well as some non-relational databases, so MongoDB, Redis, and so forth. So let's go ahead and dive into that demo, and let me pull that one up. Here you go, Rob. And maybe we need to zoom in a little bit. That was pretty hard to see, wasn't it?
Yeah, if you just want to control plus a couple times.
That's what I was trying. Let me try it again. There we go.
All right, thanks, Kevin. So I'll try to see if I can navigate, because my mouse is over here, but the screen's over there. So real quick poll. How many people leverage like proprietary database systems plus open source? Is there like migration events happening, like going from Oracle or SQL Server to Postgres or MySQL? Kind of a combo. And then how many are just on open source? Okay. Are you, another curious question, are you guys running databases within a container with like persisted storage? Yeah. Okay, containers are really popular for like stateless kind of applications, but databases are kind of new to the scene, which I think is super cool. But they're a special use case as far as that goes. Okay, cool. One of the things we do here, and I'm just going to kind of pick one at random, as mentioned, we do support a bunch of different platforms. Not sure if you guys are leveraging like RDS out there, Aurora. Okay. Did that refresh on me? I think it did. So one of the cool things we do is we standardize our approach to performance issues, meaning we're listening to the database as it tells us where it hurts. So we're just kind of a bystander, just kind of consuming all the data that's being told to us. Let's go down to a Postgres instance here, and I'll give you an example of how we do this. So if I go into the instance, yes, I've seen it. You guys may not have. But by standardizing this, in what I mean by that is that I can jump in Postgres, I can jump in MySQL, I can jump in Oracle, whatever the case may be. We're listening to this weight analysis. So in other words, where in the database engine am I spending my time? Which query's doing it? Which user is doing it? Which client machine? Which application? So we're able to dimensionalize all this data within our repository and then serve that back up to you as intel. So some things that we're doing anomaly detection, which is really just a machine learning algorithm out there, right? Kind of our first foray into AI. We're very strongly moving into Gen AI and LLMs as far as that technology goes. So more to come on that very, very soon. Can't talk too much about this, or legal will have my head. But once we do this, we can get very, very deep. But I'm gonna kind of cut to the quick here, because all this is kind of interesting. And again, we've got these different dimensions that we track the data within. But I'm gonna jump to the tuning advice, because out of this crowd, how many here own, or your company owns, the source code? Yeah? So everybody else is running, what, third-party apps primarily? Okay, this part of it anyway is going to be more for, okay, so let's cover the first. I'm kind of backing all over the place. Third-party apps, it's fine. Look, you can tell whether that system's running well, whether the database is the problem, right? It really keys in and zeroes in on what your issue is. So totally valid for third-party applications as well. The ones that do own the source code, more seems like this side of the aisle, but this is going to tell you where your code is inefficiently accessing data within the database, right? So it's making a SQL call. It's going after some kind of data, but how much work does it have to do to actually get that data and provide the answer that the query's intended for? So that's exactly what we do here. We're looking at your index structure in strategy, and there might be indexes that don't exist according to the workload and how those objects are being joined, and how that filter, that where predicate, is being parsed. We also serve up these table advisors, and in this case, I bet it's just going to be just one query where we do have an index recommendation. But I can do other things like, hey, maybe I want to see the execution plan, right? Because a lot of times you have to dive that deep into it. But really, at the biggest outset, we're looking for low ROI queries. What do I mean by that? I mean that we're asking the database engine to do a whole bunch of work to find one row or two rows, but it's having to do a ton of reads. So this lets you. So who's actually parsed an execution plan? Who's actually gone through that? Kind of sucks, right? It's not that fun. And the thing is, so you probably only do that if somebody calls in and says, hey, things are bad, right? And then you might get down to that level of granularity. So we do this programmatically. So the reason that we do this is because nobody really wants to do that. So we automated it for you. So we're looking at the workload, we're looking at the execution plans, the query plans that are being generated by the optimizer, and we're looking for those inefficiencies for you. So we put a big red X on your workload and says, if you want to tune things, if you want to optimize, start here. So this can also be shared with third-party vendor applications. You may have, mileage may vary, right? You might have some that respond really well, and then others that are like, well, whatever, our code works. So good luck with that. And then you can charge them consulting fees, which I think is kind of cool. Cool. So much more about this database analysis, but any questions about what I've shown so far? And this is kind of getting deep into the database tier of things.
You said a standalone product. Is it standalone, like on-prem SolarWinds, or is it a standalone plugin into SaaS?
So right now, as it exists, you can integrate it with the self-hosted SolarWinds solution, previously called HCO, or I'm not sure if you're familiar with that side of the house. But we're actually doing work right now to make sure that regardless of what's collecting the data and doing the intelligent analysis of that data, we're hoping to share that across all platforms. So this is going to be integrated a lot tighter into the observability story. But right now, it's a point product. It is self-hosted, so this is more of an on-prem kind of solution.
The target doesn't have to be on-prem.
No, the target doesn't have to be on-prem, and this can be run from a VM out there in the cloud as well. So you can deploy it anywhere, but yeah, you can monitor virtually anything. Cool. That's all I got.
We're running ahead.
Woohoo!
So, how many of us work with databases a lot? Anyone here? A few of us? Yeah, this does a very large amount of work for you, so that one of the most common questions we will get about, if we go back here to the home, and you'll notice up at the top we have things like alerts. We also have, when we drill down, we'll also see information about CPU and memory and those kinds of things. And your question might be, well, what's wrong with that? You can go to not just the table tuning advisor, there's an index tuning advisor and a query tuning advisor. So it will actually tell you, as Rob was showing just a moment ago, if we were to look at that, it will actually show you, by changing this index, you might experience a 8% improvement in your overall workload. So this really helps answer that question of, what do I fix? Where do I start first? Because traditional monitoring tools are very, very heavy with graphs of data. And it's like, well, you know, I'm not sure what buffer cache pending means, right? You don't have to worry about that kind of stuff and knowing what all these different performance counters and things of that nature, what they mean. You can actually just ask it to tell you, what do I fix? And the tuning advisor will give you all of that, okay? If you really want, you can look at things like, you can look at the telemetry, the specific counters. You can get all those dials and graphs, but most of our users are happy not to have to do that. Again, talking about weight statistics, the idea here is all relational databases have the concept of locking in common. You can have a deadlock on an Oracle database, a MySQL database. So you'll see that, and it'll be memory color-coded. Again, I'm sorry, memory color-coded. It will be color-coded toward whatever that weight statistic is. So we see here it's memory and CPU back on October 9th. And again, if we click on these, we can drill down and see what it was at specific times of the day, what the queries were at specific times of the day. So if you had a release at 8 a.m., you push to production at 8:30 or 9, and then you start to see these weights going up, that means people are experiencing growing greater and greater latency, and it's all because of memory issues. So what should we research at this point to find out what the problem is? Anomaly detection will tell you. It'll say, here are some things we noticed. There is a 49% increase of execution time from this one query, right? So we can drill down. It's kind of end to end, right? We start at the top of just how is our server, and we can go all the way down to the specific query or issue that's causing us a problem. So as I mentioned, I started with relational databases back in the 80s. This was hard work. And being able to have tools like this that help us is something I wish I had way back in the day, you know, and we didn't for decades. All right, so also one other thing I want to call out, if you are using virtualization software, so you're primarily on premises, you're virtualizing, we cover the major virtualization platforms like hypervisors, thank you, yes, Hyper-V for Microsoft or VMware. And one of the most common problems that a lot of shops experience with the hypervisors is what we call the noisy neighbor problem. How many of us have heard of this situation? Okay, a couple of us. So what that means is we have a VM host. Let's say it has 4 virtual machines inside of it. One is a database, one is an app server, one does its own thing, maybe it's a SharePoint or something like that. And when the host was set up, they allowed different configuration settings to be dynamic, to balloon memory if there's more memory available. Well, that's very bad for performance, particularly for databases and applications. they need a steady, predictable, reliable amount of resources available. And so imagine if we all lived in an apartment and one apartment was having a party all the time, but everybody else wants to go to sleep between 10 p.m. and 11 p.m. That noisy neighbor is keeping you up and keeping you from doing what you need to. Same thing happens in virtualization very, very often because it's misconfigured. So it's such a common problem that we actually will, I don't think this particular instance is running on a VM, but if that were the case, it would reveal that problem to you instantly and show you how to resolve it. So you can also, either through the platform that Bradley showed or in DPA, you can also get very rich alerting. One of the early lessons I learned as a database administrator was that if you rely on the phone and people calling you to tell you that things are bad, you're doing it wrong, right? People are already mad at you. Your credibility goes down. And if you were responsible for keeping applications up and running, ideally, you will know about the problem before the end user ever knows, because many times you can fix it before they ever complain. And this helps you personally maintain a high level of credibility, trust, and respect from your users. I always joke that if we're on the back end, the best we can hope for is kind of benign neglect. It's like a plumber. You know, all the plumbing is working great. Never think about the plumber. But when the toilet backs up into the house, everyone in the house is calling and screaming at the plumber, right? So we don't want that. We don't want that attention that's negative. We want that kind of nobody thinks about us, benign neglect, right? So this helps us get a hold of that entire situation where people call us and they're mad that things aren't working right. Okay, that's worth a lot to me. All right, so we're heading into the wrap up. If you have any questions, go ahead and raise your hand as well. RJ has a mic, and we'll run around and get that on the recording if you have any other questions. But before we jump off to that, I also want to point out that we have a lot of resources that you can take advantage of as well. Things like we have videos, we have white papers, lots of documentation, not just for APM, but also lots of stuff for database. So we have a lot of really talented people who blog frequently, tell you best practices, tell you new things that we've learned for best practices. For example, one thing I've been working on a lot this year, as Rob mentioned, is everybody wants to know what you're doing with generative AI. And so I and my colleagues have written a lot of content about what does that mean for your database? What does that mean for your platform? How do you keep track of a LLM and how it is processing? And so we stay up to date on what's going on, and you can rely on our sources of information as well as what you read in the community, Hacker News or what have you. And with that, thank you so much, everyone. Appreciate and grateful for your time.